Hello students, as you know that Jkssb has recently notified 190 posts for Junior Engineer Mechanical. So myself Arun and my colleague Rubin will be discussing the relevant components of syllabus in detailed format. So basically we are here dealing with the 7 components in mechanical engineering, in which Rubin will discuss the first 4 components. Now Rubin sir will continue from here. Rubin sir.
Hello students, as you see in the syllabus that we have 3 components each carrying 20 marks and 4 components each carrying 15 marks. So making the total number of components as 7. So first I'll start with the most basic topic which we have read in engineering mechanics, which is law of forces and equilibrium of forces. In this we'll deal with moment, torques, equilibriums, static equilibrium, dynamic equilibrium. Then we'll move on to moment of inertia, which has mass moment of inertia and area moment of inertia. And mass moment of inertia has its applications in theory of machines. Area moment of inertia has applications in strength of materials. Then we'll move on to laws of motion, which are Newton's second law of motion and D'Alembert's principle. Then we'll move on to friction, which is static as well as kinetic. We'll discuss both of them. Then we'll move to the application part of engineering mechanics, which is concept of simple machines, mechanical advantage, velocity ratios and their percentages. Then we'll move to concepts of stress and strain, which is very important from the basic point of view in strength of materials and has its relevance in all the other topics in strength of materials. Then we'll slowly move to elastic constants and the elastic limit. In this we'll study the various graphs, why the graphs are valid only till elastic limit in strength of materials, and the elastic constants, which are Young's modulus, bulk modulus, etc. Then we'll move on to bending moment and shear force diagram, and in bending moment we'll discuss the various bending moment diagrams at various relevant sections and the maximum and minimum shear force and bending moments at the relevant sections. Then we'll move on to stress in composite bars, which has parallel as well as series. Then we'll move on to torsion in circular shaft. In torsion in circular shaft, we'll write the basic torsion equation. Then we'll move on to series, when torsion is done in series bar, when torsion is done in parallel bar. We'll discuss both of them. Then we'll move on to columns, and there are 2 theories related to columns. We'll discuss the Euler theory and the Rankine theory. Then we'll move on to the pressure vessels, and in pressure vessels we have only thin pressure vessels and thick pressure vessel is not there in syllabus. After that we'll move on to thermal engineering and RAC. As you know, thermal engineering or thermodynamics is the basic topic of heat engineering, then in which we'll deal with heat, work and temperature. Then we'll move on to first and second laws of thermodynamics. We'll study Clausius laws, we'll study Kelvin-Planck statement, we'll study about Carnot cycle, we'll study the application part of it, which we study in power plant, which is Rankine cycle, and then we'll study IC engine application of thermodynamics, which is an Otto and diesel cycle. We'll also draw the PV and PT diagrams for water, which we study in psychometry. Then we'll study saturated, wet and superheated steam, which is a form of PV application of PV diagram and the various sections in the PV diagram, which are shown as saturated, wet and superheated steam. Then we'll move on to definition of dryness fraction of steam. This definition of dryness fraction we'll discuss with respect to PV diagram in water. Then we'll also discuss about degree of superheat of steam, which we'll discuss in the PV diagram only. Then we'll move on to Rankine cycle of steam, which is also the application of thermodynamics and we study in power plant. We'll study simple Rankine cycle. We'll study its plot on PV, TS and HS planes. Then we'll move on to Rankine cycle efficiency with and without pump work. and we'll study that why Rankine cycle efficiency is more in pump and why it is more without pump and with pump. We'll study both of the sections. Then we'll move on to concept of COP, which finds its application in refrigeration and air conditioning. And this is reverse Carnot cycle, which we'll study in refrigeration and air conditioning. As you know that there are two Carnot cycles mentioned here. This is in thermodynamics and this is in RAC. Then we'll move on to vapor compression cycle. It is also an application of RAC. Then we'll move on to refrigerants. Mostly it is theory. Secondary and primary refrigerants we'll study. We'll study psychometry, dry bulb temperature, wet bulb temperature and DPT. And these all topics are also from RAC. Then after that we'll move on to our next topic, which is fluid mechanics and machinery, which will be discussed by Arun sir. Next we'll move on to material science and production. In material science and production, we'll study the basic space lattices, we'll study about unit cells, we'll study the basic unit cells, which are BCC, FCC, and iron carbon diagram we'll also study. We'll study the classification of steels, which is mild steel and alloy steel. And in mild steel and alloy steel, we'll discuss why alloy steel is having more strength and hardness compared to mild steel. And we'll discuss what effect does various alloys have on steel. We'll discuss the heat treatment of steel. We'll discuss annealing, carburizing, etc., which are the heat treatments done in steel. Then we'll move on to welding, in which only arc welding, gas welding, resistance, special welding techniques like TIG, MIG, brazing, soldering are only there. And we do not have solid welding techniques. Then we'll move on to welding defects and testing. This is mostly theoretical topic. We'll discuss non-destructive and destructive testings. Then we'll move on to casting. Foundry and casting are the same things mostly. We'll discuss in its defects and the different casting processes. After that, we'll move on to forging, extrusion, which are the applications of metal cutting principles and cutting tools. Then we'll move on to conventional machining operations, which are lathe, milling, drilling, shaping, grinding, and we'll also do some super finishing operations in it, which are honing, reaming, boring, etc. As you can see, these topics are mostly theoretical, so in it the chances of numerical portion are very less. So we'll deal mostly with the theory in this part. Now we'll move on to the fourth topic, which is industrial management and CAD/CAM. In industrial management and CAD/CAM, as you know that 50% topic are only there, which we have studied in our college. So mostly theory will be there from industrial management, which we'll do the planning, the organizing, leading, controlling, inventory control. These are all theoretical topics. Then we'll move on to inspection and quality control. Quality control is little numerical based, rest all topics are theoretical only. As you can see, there is no sequencing, there is no scheduling, there is no line balancing. So these topics were numerical topics, but it has not been taken in JEE syllabus, so we will not discuss about it. Then we'll move on to CAD/CAM, which is a very theoretical topic plus a very tedious topic and a tricky topic. So we'll discuss about CAD/CAM what is basically CAD and CAM, and then we'll discuss about numerical controls, direct numerical controls, CNC machines, how from punch tape to computer tape to multiple computers we innovated and we moved. So these are all the topics that will be that I, Ruben, will be taking into account. Rest topics will be discussed by Arun sir. So I give this platform to Arun sir to discuss this.
Thanks, Ruben. Thanks for this kind gesture and for introducing me. Students, let me just highlight with the theory of machines and the machine design portion. As you see, in theory of machines, firstly we are dealing with the 4-bar linkages and the link motions. Here we will discuss all the relevant basic introduction part, the numerical parts, single slider crank chains, double slider crank chains. I'm just giving you a highlight. Rest we will deal in the class when it comes to just class works. Flywheels, fluctuation of energy. As you see in flywheels and fluctuation of energy, the question is basically from numerical point of view. And from 4-bar linkages, here questions that come mostly in exams is theoretical. Next topic is the power transmission by the V belts. Again, it is a theoretical portion. In flat belts and V belts, there is some derivation part, but we will discuss that particular derivations in the classwork. And the numerical in the context of V belts and flat belts are basically just objective, and it's like somehow difficult, but we will discuss the relevant formulas and we will discuss all the previous year's questions which was like already already being asked in the exams. So we will take there into consideration. When it comes to gears, as you know, the gears are different types: involute, cycloidal gears. We will all discuss that topics in the class. Gear profiles, it's basically a theoretical portion. There are to discussing a gear profile, it's basically that angular geometry. So we will discuss that particular in class. Cams and followers, it is a theoretical portion. Its classifications, so governors, different types of governors, just like Watt governor, Hartnell governors, different types of governors. On the there are basically different types of governors. We will discuss that topic in the class. And when it comes to governor, mostly almost 2 or 3 questions from theory of machines and the topic of governors is being asked in these recently exams. When it comes to the machine design portion, it is basically a very important. The students being eliminate this and take very lightly this machine design portion. We will discuss important questions when it comes to design of shafts. We will discussing keys. We will discussing riveted joints. We will discussing the couplings, just like flange couplings, muff couplings. After that, we will be discussing taking fluid portion. In fluid portion, as you see, basically properties here we are discussing the chemical properties and the physical properties relevant to the fluids. Then we have to classification of fluids. Classification of fluids, we will discussing the classification on the basis of Mach number. It is very important. Usually the classification is basically done on the basis of phases, but usually teachers eliminate this particular classification on the basis of Mach number. I will discuss it by myself in the class. When from the classification on the basis of Mach number, the question is being asked in the recently CBT examinations. Then we'll be discussing the Newton's law of viscosity. In Newton's law of viscosity, it's basically a very stress and strain kind of relationship, and it's basically a numerical part. The objective being asked is numerical in nature. Then we will be discussing the fluid statistics. We also discuss the different type of manometers, just like here given U-tube manometers, inclined manometers. There are different manometers as well. As you know that manometers are used for measuring the pressure differences. We will discuss. This is a all numerical part. We will discuss these topics in the class. Then the second portion in the fluid is kinematics. So here we will discussing the different types of flows, the laminar flow, turbulent flow, external flow, internal flow. We will discussing uh, uh, in uh, in these topics, laminar and turbulent flow, irrotational flows, rotational flows, uniform flow, non-uniform flow, and the different types of how laminar changes into turbulent. Bernoulli's equation is also one such topic. We will discussing the velocity heads. These are basically concerned with the dams portion, just like with Pelton wheel. We will discussing the Pelton wheels. We will discussing the Francis turbine. We will discussing the Kaplan turbines and the different types of turbines basis on the flow. Some of them may be Maxwell, some of them may be radial. We will all discuss the all relevant flows discussing with the turbines. Then we will comes basically the measurement of this pressure. Then here the equipments or instrument being used. It's Venturi meter or Pitot tube. As you know, Venturi meter is used for measuring the pressure difference between the 2 points. Pitot tube is used for measuring the velocity of air, some object. It can be used for measuring the velocity of air. It can be used for measuring the velocity of fluid. Orifice meter again used for measuring the discharge. Hydraulic turbines, one of the most important topic. Fluid machinery. So we will all discuss all the relevant. And the last topic is centrifugal pumps. In centrifugal pumps, we will be discussing the priming. We will discuss the suction head. We will be discussing the delivery head and all the relevant topics in the class. Next topic we are discussing here is, just wait, is metrology and automobile engineering part. In metrology, we will be discussing with the tools used in the linear measurement. So the tools here used in the linear measurement, we will be discussing here with the vernier calipers, the micrometers, the difference for angular measurement. We will be discussing the one of the most important is Tomlinson micrometers. There are different wave measurement techniques. There are different here we are discussing the angular measurements or the wavelength part of this. This is also one of the most important part. Okay. Then we'll be discussing surface finish and the tools which were used for measuring the surface finishing. Limits, filters and tolerances. It's one of the most basic element when it comes to metrology, and it's also very simple. We will be discussing what the questions are being asked in the previous examination or in any examination being asked in different state. Errors, we all know errors, the different type of errors, systematic errors, measurement errors and different types of errors. We will discuss that particular things in class, and it's also quite a very theoretical part, the metrology. When it comes to automobile is also theoretical but quite heavy, or it takes a little bit, it takes toll actually, to discuss all these when it comes to in automobile. This classification of automobiles, so here we'll be discussing, it's a very simple thing. When it comes to transmission, the transmission is basically a 2-day chapter. Steering again 2-day chapter. I think this particular portion will take you around 15 days to get completed. So it's also one of the most important topic, but usually eliminated by the students. Not eliminated, but taken in very lightly. And basically just these are the topics which decides the rank. So we will be discussing it on a very, very, very serious mode. These topics are being usually taken for granted by the students, but we are basically looking to crack these examinations. So for that, we can't eliminate such topics. These are the merit scoring areas. So automobile engineering is a merit scoring area, so as is metrology. So as you know, students, we at Spark Institute will be starting new batches at the Spark Institute within few days. So serious candidates who are looking forward to crack this examination and to get selected in the government services can contact the management for any doubt, for any queries as soon as possible. Thanks and regards.